Hello guys, today we are going to deal the particular integral in case of higher order differential equation with constant coefficients. Okay, so we have some special cases for the particular integral or for the PI. Okay, it will depend on the different categories associated with the function capital X. Okay, for example, if our capital X is of the form of e to the power x, then what about the pi? So pi will be calculated with the formula 2 for two formula, like formula 1 I am writing here. It is as if your 1 upon f of d e to the power x, if your uh, expression is of the form, okay, then you can rewrite it to find the pi. You can write it as 1 upon f of a e to the power x, but provided that f of a should be non-zero. Okay, and the formula 2, if your f of d is some power of the same linear factors, for example d minus a to the power n and e to the power x, so in that case you can find the particular integral as x to the power n upon n factorial, okay, and e to the power x. Fine, you have these two very important formulas to deal the particular integral when your capital X is of the exponential type. Okay, so now we are going to deal another format of this. Your f of d may be of the form in case f of a is equals to 0, right? It is the working methodology also, you can say the working methodology or working rules. Okay, so number one, you will check if it is f of a is not equals to 0, so your pi will be calculated with this formula, or if your expression is of the form, then your pi will be calculated with this formula. In case if f of a is equals to 0, then so f of a f of d will be of two form here. Okay, either it will be equals to d minus a to the power n, then if your f of d is of the form this, then obviously you will apply this formula. Okay, and you can get your answer very easily. In case if your f of d is of the form like there are some factors of a, that is d minus a to the power r, and we have f of d, okay, some other function of d, okay, then and provided that f of d is not 0, provided that f of a is not 0, not d, f of a is not 0, then your particular integral will be decided by as 1 upon x to the power r divided by r factorial and phi of a e to the power ax, okay, with this form. So guys, remember this thing, if your capital X is exponential type e to the power ax, so you will apply this theory. Okay, it is the exponential type in case of your capital X is the exponential function in terms of e, then you will apply this theory to find the particular integral. And one thing to be noted here, if small a is equals to 0 and capital X is equals to 1, so obviously your particular integral will be look like d to the power n and e to the power 0, e to the power, sorry, in place of x you will write it. So what about this integration, what about this value? So you will find that you can write it as d minus 0 to the power n and e to the power 0x, obviously. So you can apply this formula and you can write simply x to the power n upon n factorial, okay, in case of this, okay. And if your f of d is not of this form, so obviously you can say 1 is equals to, that is 1 upon f of d and e to the power 0 into x, and you can write as f of 0 into 1, okay. But provided that f of 0 should not be equals to 0. So we have this theory to find the particular integral, okay. Now we apply this theory on some question number 1 we are going to deal here. Solve the differential equation d square minus 3d plus 2y is equals to e to the power 3x. Now come on. Now solution is quite simple. Here we need to find complementary function and particular integral. So obviously the auxiliary equation to find the complementary function is m square minus 3m then plus 2 is equals to 0. Now you can middle term is split to plus 1 m plus 2 is equals to 0, and m square minus 2m minus m plus 2 is equals to 0. You can take m common, m minus 2 minus 1 common, m minus 2 is equals to 0. So m minus 2 and m minus 1 is equals to 0. So you are here two values of m and which are real and distinct. Both the values are real and distinct. So you can decide your complementary function as c1 e to the power x and then plus c2 e to the power 2x, okay. Now what about the particular integral? Here we need to find the pi. So for the pi you can write here 1 upon f of d, okay, for the pi f of d and e to the power 3x. So what do you mean by f of d? That is d square minus 3d plus 2 e to the power 3x. Simply we substitute here 3, okay, that is 3 square minus 3 into 3 plus 2 e to the power 3x. So in result you will get 1 upon 9 minus 9 then plus 2 e to the power 3x. It is cancelled out. So you are getting 1 by 2 e to the power 3x as a particular integral. Now what about the general solution? So general solution is nothing but the complementary function plus particular integral. So what about the complementary function? c1 e to the power x plus c2 e to the power 2x, and then particular integral is 1 by 2 e to the power 3x. So it's quite simple to study, okay. So we have the final solution here, and to understand the complementary function and particular integration we will study some more questions too. Question number 1, solve for d square plus 12d and plus 9y is equals to 144 e to the power minus 3x. Guys, we need to solve this question. Okay, now obviously first we find the auxiliary equation. Okay, so for the auxiliary equation we have 4m square and plus 12m and then plus 9 is equals to 0. Here we can middle term split. Okay, 36 and 6 plus 6 12. So you can take here 4m square and then plus 6 plus 6m and then plus 9 is equals to 0. Obviously we are middle term splitting here, so 4m square then plus 6m and plus 6m and plus 9 is equals to 0. You can take 2m common here, so 2m plus 3 2m plus 3 and then you can take 3 common here, 2m plus 3 is equals to 0. So you are here 2m plus 3, I think it is whole square equals to 0. So simply here you have m is equals to minus 3 by 2 and these are two repeated roots. Okay, 3 by 2 and 3 by 2. So you have your complementary function as c1 plus c2x, okay, and e to the power minus 3 by 2 x, right? Now decide particular integral. Now to decide the particular integral we need to find 1 upon 4 d square and plus 12d and plus 9 and 144 e to the power minus 3x. So you can take 144 as a constant outside. So now you can substitute in place of d minus 3. So 4 into minus 3 square and plus 12 into minus 3 and then plus 9. Okay, so it will be e to the power minus 3x. Now solve it. 144 and 1 upon, okay, 4 into 9 and minus 36 and then plus 9 e to the power minus 3x. So you can write here 144 divided by, it is 36 cancelled out, 9 e to the power minus 3x. So it is your pi. What about the general solution? So your general solution will be decided by c plus pi, that is c1 plus c2x e to the power minus 3 by 2 x and plus 144 whole divided by 9 e to the power minus 3x, which is another simple question here. Now I am going to deal the another question on the same theory, and we have the question for example d square, solve d square and plus 2pd and plus p square and plus q square y is equals to e to the power ax, e to the power x. We need to solve this question. Okay, and now solution. First we write the auxiliary equations. So auxiliary equation will be written as, you can write in terms of m square plus 2pm and then plus p square plus q square, okay, is equals to 0. Now it is a quadratic in terms of n, in terms of m. So you can decide here, you can apply here Sridharacharya rule. Okay, 2p and then plus minus, because we have minus b plus minus square root, how we will decide the ABC. I am writing here the Sridharacharya formula, x equals to minus b plus minus square root b square minus 4ac divided by 2a. This formula decides the two roots of any quadratic equation, and ABC is what? Just compare the given equation in terms of the quadratic general equation. Okay, am square plus bm plus c equals to 0. So minus 2p, okay, minus 2p plus minus square root b square means 4p square minus 4a b minus 4ac, okay, good, and then divided by 2a. 2a means 1, okay. So from here now you can find the value of ABC. The value of A is 1 and the value of B is 2p and the value of C is p square plus q square. So finally you will find here 4p square and 4p square is cancelled out. So you have inside minus 4q square. So you can write it as plus minus square root of minus 4q square whole divided by 2, and you can rewrite it as minus p plus minus iota q, okay, plus minus p plus minus iota q. So you can write your complementary function here, okay. You have your root in terms of complex conjugate. So it will be written as e to the power minus px, right, and c1 cos qx and plus c2 sin qx, right. It is your CF. Now to decide the particular integral, we write it as 1 upon d square and plus 2pd and then plus p square plus q square e to the power ax, e to the power ax. So you can write, you can just simply replace d upon a. So you can write a square plus 2ap, okay, and then plus p square plus q square e to the power x. It is your pi. It cannot be solved further, okay. So you can write the general solution as CF plus pi, that is e to the power minus px, and c1 cos qx and then plus c2 sin qx, right, and then plus 1 upon a square plus 2ap and then plus p square plus q square, okay, e to the power ax. So it is your final answer, okay. And we have the simple and same methodology for each and every questions. Now we will deal 2 more questions to support this theory. Now for example, solve the differential equation d square and d plus 1 whole square and d square plus d plus 1 whole square y e to the power x. Guys, remember, there are infinite number of questions, but the methodology is unique for each and every question, okay. We have the unique methodology, we have the general methodology to solve, okay. So simply first we write here auxiliary equation as m square m plus 1 square and m square plus m plus 1 whole square equals to 0. It will give you the 2 repeated roots 0, 0, and it will give you the another 2 repeated roots at m equals to minus 1 and minus 1. And what about this? Obviously we will apply here the Sridharacharya. So you will get value of a is equals to 1, b is equals to 1 and c is equals to 1. So minus b plus minus square root b square means 1 square minus 4a and c, and then divided by 2a. So you will get here minus 1 and plus minus square root of minus 3 iota, minus 3 divided by 2. So you will get here minus 1 plus minus square root 3 iota by 2, okay. And we have root of this m square plus m plus 1, but here we have the square, so we have these roots are repeating, okay. So we have here 4 and 2 6 8 roots are there, okay. 2 are repeated alike, 2 are repeated alike, and two complex conjugate pairs are repeating alike. So complementary functions will be decided and will be written the very careful. So c1 plus c2x and e to the power 0x means 1. Okay, and then plus c3 plus c4x for these two roots e to the power minus x. Now c5, okay, we have here the repeated complex roots are repeating. Two repeated complex roots are there. So you can write it as e to the power minus 1 by 2. Okay, and c5 plus c6x. Okay, and cos square root 3 by 2 x, right, and then plus c7 and plus c8x and sine square root 3 by 2x. It's your complementary function. Now for the particular integral, you can write 1 upon d square and d plus 1 square and d square plus d plus 1 whole square e to the power x. Obviously, simply you will write here 1 in place of d. So you will get 1 square, 1 plus 1 square and 1 square plus 1 whole square e to the power x. So finally you will get 1 into 2 into 3 square e to the power x. So finally 3 3s are 9, 9 2s are 18. So 1 upon 18 e to the power x is your particular integral. And the general solution will be written as CF plus PI. Okay. So I think you guys understood this point very carefully. Okay. So we have the number of questions for finding the complementary function and the particular integral. So to support this theory, I would love to find the another questions also, to discuss the another question also. In continuation to this theory, now we solve this question and we have the solution is, first we write the auxiliary equation, okay, to find the complementary function, and it is m square plus 4m and then plus 4 is equals to 0, and you can simply write it as m plus 2 whole square is equals to 0. So you have simply here two repeated roots minus 2 and minus 2. So complementary function will be as c1 then plus c2x and e to the power minus 2x. Okay, now for the pi part, particular integral, how we will decide it, you can we write it as 1 upon d square and plus 4d and then plus 4. Okay, now you can write 2 sine hyperbolic x. Okay, now you can write 1 upon d square plus 4d plus 4 and 2 times sine hyperbolic x. You have studied this. Okay, you can be written as e to the power 2x and minus e to the power minus 2x whole divided by 2. Okay, so it is your, so you can write it as 1 upon d square plus 4d and then plus 4 e to the power 2x and minus 1 upon, or you can write it as also d plus 2 ka whole square e to the power minus 2x. Obviously if we replace here d with 2, so it will be 2 square plus 4 into 2 and then plus 4, and here e to the power 2x. If you replace here d by minus 2, so you will get 0. Okay, then you can apply here 1 upon d minus a to the power n e to the power ax formula, that is x to the power n upon n factorial e to the power ax. Okay, so for this you can say x square upon 2 factorial and e to the power x square upon 2 factorial and e to the power minus 2x. Okay, and what about this 4 into 4 or 4 8 and 4 plus 4 8 and 8 16. So 1 upon 16 e to the power 2x and minus x square by 2 e to the power minus 2x. Okay, it's your particular integral, and the general solution will be decided as CA plus pi, that is C1 and plus C2x e to the power minus 2x, okay, and then plus 1 upon 16 e to the power 2x and minus x square by 2 factorial e to the power minus 2x simply. Similarly, we have these two questions also. With the help of same theory we can find, and in the question number 1 we have the repeated roots here. That is I'm writing here the roots directly as m equals to minus 2 and m is equals to 1 1 1. Three times repeating roots are there. So complementary function will be decided as c1 e to the power minus 2x and then plus c2 plus c3x plus c4 x square and e to the power x. Okay, it's your complementary function. For pi part you can write it as 1 upon d plus 2 and d minus 1 to the power 3 e to the power x. Okay, obviously this part will be 0 for d equals to 1. So it is your phi of d. You can apply here the formula d minus a to the power r and phi of d e to the power ax formula. Okay, that is what x to the power r upon r factorial and f of a, provided that f of a should be non-zero, e to the power ax. So come on, you can write it here 1, so it is 1 by 3 and x to the power 3 upon 3 factorial, right, and e to the power x. Okay, so your pi will be decided at 3 to the 6, 3 factorial is 6, 6 3 is 18, 1 by 18, x to the power 3 and e to the power x. So your general solution will be decided decided as e to the power minus 2x and plus c2 plus c3x and plus c4x square e to the power x and then plus 1 upon 18 x to the power 3 e to the power x. It's your general solution. Similarly, you can solve the second part of this. It's quite easy to solve, guys. I think you guys understood all the types of questions based on the exponential form. If your capital X is exponential form, then you can solve it with this methodology. I hope you understood, and I again request everyone to like, subscribe, share and comment on the videos. You can also suggest the topic. Thank you very much. See you in the next video.